Right. I'll take the usual topology. We have router 1. Say this belongs to autonomous system 10. And this is connected to router 2 and router 3, router 4, router 5, router 6, and let's say we also got router 7 and then router 8. This middle one is autonomous system 20 and this is autonomous system 30. Right. Now when I advertise 1.1.1.1, that advertisement must reach R8 if I want to ping from here 1.1.1.1. Now, what all I need to do to achieve this? Can someone explain step by step? Assume IP address is assigned on every interface and BGP neighborship has already come. Start from BGP. Yep, start from BGP. Assume that only IP address is given and OSPF is running on all this router. And no OSPF here. No OSPF here. I want to ping from this loopback 1.1.1 to 2.2.2. Likewise, I want to ping from this 2.2.2 to 1.1.1. What all I need to do? Good. Good. Let me go step by step. Yeah. So we first of all form eBGP here. Right. eBGP is done. Right. Now I want something need to be considered before what you are saying. You said you want to do next stop self. That's okay. But what sort of neighbor I need to form in this autonomous system? How many iBGP neighbor R2 will have? How many iBGP neighbor R2 needs to have? Correct. 6 or 5 iBGP neighbors. 5, that's what fully mesh. Likewise, how many iBGP R4 will have? Same, correct. Right. That's very important. Now it is fully mesh. Okay, it is fully mesh. That's right. Now, if I don't want to make it fully mesh, what will be the problem? I don't want to make fully mesh. Good. There is a split horizon issue. Now, is there any other way that we can solve split horizon issue without making fully mesh? Is there any other way to solve the split horizon issue without making fully mesh? The way we have not discussed about that, so you don't know. The other ways to do it is what? BGP configuration and route reflector. Route reflector and BGP configuration can be used if you don't want to make fully mesh When I make fully mesh, what is the problem? I give too much of pressure over subscription on this router. Now this router has to send the update to R5, R6, R3, R4, R2. Same update packet is being duplicated many times and given to 5 different neighbor. Instead of doing this, instead of making fully mesh, instead of having 5 neighbor, you have just only the directly connected neighbor. So router 2 will have only 2 IBGP neighbor with router 3 and router 4. Not more than that. Router 3 will have with router 5 and router 2. So only the directly connected neighbor you can have. To override split horizon issue, we have route reflector. See how meaningful. You're going to do what? You're going to reflect the routes. Route I'm going to reflect the routes. I'll go to R7. Okay, not R7. See, whatever R7 is receiving from R8, it will give to R5. We all know that. It will give to R5 and it will give to R6. But R5 and R6 will not give to R3 and R4. That is what split horizon issue. Similarly, whatever is coming from R2 will come to R3 and R4, and R3 will not give to R5, will not give, R4 will not give to R6, and vice versa. Even 6 also will not give to 4, 5 also will not give to 3. This is what split horizon issue. What I am going to do is, I am going to reflect those routes that is there in R5. R5 is not giving. I am making it to reflect it. I am making it to give. I am going to tell router 5, give it to router 3. How? By configuring a route reflector. I am going to say reflect all the routes that you have to 4. Give it to 4. That's the other meaning. Likewise, I am going to tell to R3, give it to 5. Give it to 6, which is called route reflector. Making this IBGP to give to other IBGP is what called as a route reflector. Now how to do this? Very simple. Go to router 5 and say router 3 is your route reflector client. Router 3 is route reflector client. Command is very simple. Go to router 5. In router 5, inside BGP, I need to say, let's say router 3's address is 3.3.3.3. I'll say neighbor 3.3.3.3 is a route reflector client. That's the command. That's all. When I give that command here on R5, R5 will give to router 3. Now, this 2.2.2.2 was seen here on R7 and it was given to R5. Now R5 is also giving to R3. Now will R3 give to R2? No. Again you go to router 2 and say router 2 is your client, route reflector client. Similarly do it on R6. Go to R6 and say 4 as client, go to 4 and say 2 as client. When you do that, this 2.2.2.2 will be seen on R1. Likewise, 1.1.1.1 is seen on router 2 and router 3. So I go to router 2 and make 5 as the client. Likewise, I will go to router 4 and make 3 as the client. Likewise, go to router 5 and make 7 as the client, 6 as the client. When you do that, you will see router 8 having 1.1.1.1. Is there any doubt in this? Client. Okay. Now, what I explained now is to make you understand easily. But let me make it a bit complex. Let us repeat again the same thing. Slight change will be there in my explanation now. But whatever I said, if you do, definitely it will work. But you need not to do that much configuration. See, I am seeing 2.2.2.2 on router 5 and router 6. Likewise, I am seeing 1.1.1.1 on router 3 and router 4. 1.1.1.1 is seen on router 1 and router 3. Sorry, 3 and 4. 2.2.2.2 is seen on router 5 and router 6. All that you need to do is any one router you go, router 5 you go and say 3 as client. When you say that, R3 will start giving 1.1.1.1 to router 2 without you saying router 5 as a client here. That's the secret. 3 and 5 are not giving. You just go to any one router and say the other router as neighbor. Not only server will give to client, even client also will give to router to the server automatically. That is what the point I want to make. If you make one-way communication, the other way you need not to make. It will happen automatically. So, when I say to router 5, 3 is your client, 2.2.2.2 will go here. Not only that, 1.1.1.1 also will come here on R5 without me saying 5 as the client. This is very important secret. You need not to go to both the router and say that. You say on one router, the other router will automatically start giving whatever it has. So R5 will receive it. Which one? 1.1.1.1. But what about R5 and R7? Here you need to say 7 as the client. That's all. Likewise here you need to say 2 as a client. We need not to say 5 as a client on R3 and 6 as a client on R4. That's what I meant. Or if you go to R4 and say 6 as the client, you need not to go to 6 and say 4 as the client. This is what route reflector, very easy. And this video is already shared to you. Please have a look at this. Right? I definitely want you to finish all the BGP related videos that you have, which I have shared with you before tomorrow. So tomorrow we will actually finish the remaining EIGRP, and then we'll get into switching. We need to get into switching soon. We had a plan of finishing CCNP this week, but again it is going to one more week. So this is route reflector. Now configuration is the next topic. BGP configuration. This configuration BGP configuration is again another solution for the same problem. I got router 1 in AS10, router 2, same diagram I am drawing, router 3, router 4, 5, 6, 7 and 8. This is in AS10, this is in AS20, and this is in AS30. Now, 1.1.1.1, 2.2.2.2, or let's say 8.8.8.8. I want to ping from 8 to 1.1.1.1, and I want to ping from 1.1.1.1 to 8.8.8.8. Same thing, all configuration is needed, whatever we discussed, next hop self, all those stuff. But the thing is, we are not going to make fully mesh. R2 is neighbor with 3 and 4, that's all, IBGP neighbor. R3 is neighbor with 5 and 2, that's all. So, one solution we saw is fully mesh, the other solution we saw is route reflector. The third solution is confederation. What it is? You see, this 1.1.1.1 is seen in router 3 and router 4. And 8.8.8.8 is seen in router 5 and 6. It is seen in this both. And they are not ready to give. 3 is not giving to 5, 1.1.1.1. 5 is not giving to 3, 8.8.8.8. We are not going to reflect route, or we are not going to make fully mesh. We are going to solve it by using BGP confederation. You know what you need to do? Create a sub-autonomous system inside this autonomous system. Very, very important. I am trying to make a eBGP relationship between these two guys. Why, you know? Between eBGP, they don't have any problem in giving. Actual autonomous system is 20. Inside I am creating autonomous system like 3500, 35200, something like this. I am creating sub-autonomous system. Why I do that? So that R3 and R5 will feel as if they are eBGP and give this 1.1.1.1 to 5 router and 8.8.8.8 to router 3. The sharing will happen when they are IBGP. Split horizon rule is for split horizon rule is for only for IBGP. Now, because they have a kind of eBGP relationship, the router 4 and router 3 has got a kind of eBGP relationship, they will share. But actual autonomous system they belong to is 20. There is a command called BGP identifier. You will see in that video. That will tell to R2 will say to R1, hey, I am actually 20, but I am running 35,100 just for my local purpose. To solve my local problem, local issue, I am running it, but my actual autonomous system is 20. You will see that me giving the command called identifier, BGP identifier command. So these autonomous systems are like sub-autonomous systems. They are local within this autonomous system. According to the other autonomous systems, you are not 3500 or 35200, you are just 20. But internally, according to 3 and 5, 3 belongs to 3500, 5 belongs to 35200. This is what BGP configuration is. It's really interesting part. If you do it, you will really like it. But before you do, at least see the video completely twice. Once you learn the concept, understand, and then the second time when you see, you take down those commands, and third time you design your own topology, give your own IP address and try off your own. When you do this, you finish BGP. BGP route reflector and BGP configuration. This is not there in CCNP, but I have taken this because I promised someday before to Pooh that I will take this. We have finished this though.